Alright, so today we're going to be doing 5.2, which is binomial theorem, or Pascal's triangle. So Pascal's triangle was originally developed by the ancient Chinese, but Blaise Pascal, a famous French mathematician and philosopher, was the first person to discover the importance of the patterns it contained. Pascal's triangle is more than just a big triangle with numbers. There are two major areas where Pascal's triangle is used. It's used in algebra and also probability and combinatorics. So before we get into actually using Pascal's triangle, I first want to make sure that you're all on board and understand how to do basic exponential operations, which we learned about in 5.1. We learned that anything to the 0 power is 1. We learned that if we put anything negative to an even power, it's going to become good. But in some cases, you have a negative on the outside, so it's going to stay negative. Anything negative to an odd power is going to stay negative. And then I multiply that by 4x, which gives me negative 32x to the 4th. Do you guys like smell that in here? Like it's like spray chlorine or something? Whatever you want to call it. And then this one's going to become negative 8x cubed times 16y squared, which will give me negative 128 x cubed y to the second. Alright. So now that you're good with all that, that stuff is going to come up throughout this lesson a few times, so I'll explain why that's so important. So the next question says to expand x minus 2 to the 4th power. So that means that it wants us to multiply x minus 2 times itself 4 times. Okay. So to do that, we have to multiply these two together, and we have to multiply these two together. Okay. So to multiply the ones in the yellow together, x times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. And then lastly is going to be positive 4. Now you're going to have to combine like terms, so you end up with x squared minus 4x plus 4. And we have to multiply that by what's in the blue. Now, do we have to multiply what's in the blue out? No, because we already know it's going to be the same thing as the other one, right? So now I'm at the point where I have to multiply these two trinomials together. So the other day I taught you guys how to multiply anything this big together, and I said to use the box method. Remember this? So you're going to create a box, and that box has to have 3 this way and 3 the other way. So you're going to create a box with 9 sections to it. And I know it's 9 sections because it's a 3 by a 3, right? So then you're going to put these numbers on the side, like this. And then we have the numbers this way. And then we're just going to multiply the corners together. X to the 4th minus 4x cubed plus 4x squared minus 4x cubed plus 16x squared minus 16x plus 4x squared minus 16x plus 16. And then we're going to find, can you please not lean on the light? Because you keep turning it on. The last one, other one, on the other side. Hit it. And then just stop leaning on it, please. Alright, so now we're going to combine these like terms here. So we've got x to the 4th minus 8x cubed plus 24x squared minus 32x plus 16. And that's going to be our final expanded answer. Now as you can see, this was a lot of work, and this was only to the 4th power. So you could imagine multiplying something to the 6th power, 7th power would take you quite a while, right? So that's why we use something called Pascal's triangle, which is kind of a shortcut. on how we do this. So, to generate Pascal's triangle, let's just talk a little bit about what it is, how it works. So you notice there is a pattern here. So Pascal's triangle always starts with that triangle shape of the 3 ones. Okay? And that first row we call row 0. Okay, that very first top row we call row 0. The next row is row 1 and so on. Okay, so this is row 0. This is row 1. And then row 2 and so on. So the row that you're in corresponds to the exponent that's on that binomial. Okay? So, what you're going to notice is as Pascal's triangles goes down, there's always a 1 on the outer edge, and then we're adding these numbers together to get that next number. You see that? I'm adding these numbers together to get that number. I'm adding these numbers together to get that next number. So everybody see that pattern a little bit. Okay. So we're going to practice generating our own Pascal's triangle. Here's another representation of it, but let's go ahead and try to create our own. So, you're not expected to necessarily memorize Pascal's triangle, but you have to know how to generate it at any given time. So, to generate Pascal's triangle, you always start with the 3 ones on the top like this. And then the next row, we know the outer edge will always have 1s. And then what's going to happen is you add these 2 together to get the next term. What's 1 plus 1? 2. Good. So then we put another 1 on the outside. Bless you. What is 1 plus 2? 1 plus 2 again? 3. So to keep you in balance here of what's going on, this is row 0. This is row 1, row 2, and row 3. You know you're doing it right when your row has 1 more than the row you're in. You see that? Row 0 has 1. Row 1 has 2 numbers. Row 2 has 3 numbers. Row 3 has 4. Okay, that's how you know you've been doing it right. So now we're going to do row 4, which is going to have how many numbers? 5. 1 plus 3. 1 plus 3. And 3 plus 3. Good. That's row 4. Put your 1s on the outside. 1 plus 4. 1 plus 4. 4 plus 6. We got 2 10s. That's row 5 with 6 terms. Then we've got 1 plus 5. 6. Of course, we got our 1s on the outside. 10 plus 5. And then we have 20, right? Okay. That's row 6. And the last one we're going to do for now is row 7. This goes on infinitely, by the way. This next one is going to be 7, right? What's this one going to be here? 21, 35, 35, and 21, right? So does anyone have any questions about how we generated Pascal's triangle? Okay. So now we're going to learn how we can use Pascal's triangle to help us expand polynomials. So, you want to expand the polynomial x plus y, a binomial, with a power of 6. So the power on that binomial tells you what row of Pascal's triangle you're going to use. So we're going to use row 6, which has what numbers on it? Good. So I'm going to take row 6 and I'm going to put it in here. Like this. What is that going on right now? No, like it's like somebody like sprayed something strong like right by my desk. Alright. So, what we're going to do now is we're going to identify the first and the second term. Your first term is going to be called A. Your second term is going to be B. So what is our first term in the binomial? What is our second term? Y. Now we have to use something called the binomial expansion, okay? As you expand the binomial, here's how the exponents go. You take the first coefficient, which is the very first item that you listed for row 6. That's going to be your first coefficient. Now, whatever your first term is, you're going to put to the power of whatever this is. So you're going to put it to the 6th power. And your other term is going to be to the 0 power. As you go on, the first term is going to decrease in power by 1. The second term is going to increase in power by 1 until you get through it. So it's going to make sense once you start seeing it. So the very first term is going to have the coefficient of the first value of the row, which is 1. And then it's going to be first term to the 6th power, whatever the original power is, and then your second term to the 0 power. Okay, that's how you always start it. Whatever your power is, whatever is 0 power. Then you're going to take your next coefficient, which is 6. Now you're going to take your first term, it's going to go down a power. So if it was 6, it's now going to be 5. The other one's going to go up a power. So if it's 0, it's going to be 1. Now you're going to take your next number in the sequence. So it's going to be 15. It's going to be x to the 4th, y to the 2nd. See how the power of one goes up as the power of the other goes down? Okay, we'll try one more time. This is going to be 20, x to the y to the. See how one goes up, the other goes down. Okay? Next one's going to be x to the 2nd, y to the. Good. Next one's going to be x to the 1st, y to the. Good. And the next one's going to be x to the 0, y to the 6. So you're going to notice these reverse. Whatever we started with x to the 6, y to the 0. We end with x to the 0, y to the 6. Another important thing to note about this, what do your exponents always add up to?
6.
For each term. They're always going to add up to 6, the original exponent. Okay? So now from here, you guys are going to write it as an expanded polynomial. Okay? So here's how you do that. You can simplify this down a lot. There's a lot of unnecessary stuff here. Anything to the 0 power is 1. Coefficient of 1. Do we need to write that? The only thing we have to write here is x to the 6. Then we have just plus 6, x to the 5th, and y. Then we just write these middle ones because we can't do anything to simplify those. So I'm just writing those ones in the middle that don't simplify at all. I don't need to write an exponent of 1. And then the very last one is just y to the 6 because x to the 0 is just 1. Okay? So this is what you would obtain if you multiplied x plus y together 6 times. That's what we just did without doing that. You see what I'm saying? We used Pascal's triangle to do that multiplication for us. So that's what the purpose of us doing this is. Alright, so this problem was pretty easy because our terms were very simple. We had x and we had y. Sometimes your terms are not that simple. That's where things get a little bit more convoluted. Okay, so let's try one that's a little less simple. Oh wait, I forgot to fill in the side. Our first term is x. Our second term was y. To simplify this, we used the expansion, which had 7 terms. The fourth term would be 20, x to the 3rd, y to the 3rd. And there are 7 coefficients in the row. Okay? Alright. Now, we're going to expand something a little bit more complicated. So, before I get a million questions about it, yes, I know we accidentally put an x here instead of an a. Okay, so just go ahead and fix that so you don't, get confused. This should have been an a, not an x. A, not an x. You guys got that? Okay. So, now we're going to go ahead and expand this polynomial. So first thing we have to do is we have to identify what row of Pascal's triangle we're going to use. What row are we going to use here? Good. What is the 5th row? 1. I think that's it, right? Okay. That's the row we're going to use because that's the exponent. Now you have to identify each term. Our first term is going to be 3a. Our second term is negative 2.
How did you get that?
I just took it right from the binomial. You see?
Oh, okay. Sorry.
No, it's okay. So,
From the top probably.
like I said, sometimes they're not going to be just as simple as x and y. You have to take multiple things with you. Okay, that's still a whole term. Now we're going to do its expansion. Now this is super important. Okay? Please do not make this mistake. When you're putting something like this to a power, you need to put it in parentheses. Okay? The only time you don't put it in parentheses if something simple like x, y, just you don't have to. But if it's anything with a coefficient, with a negative, with a power, have to put it in parentheses. Because if you're putting 3a to the 4th power, you have to put the 3 and the a to the 4th power. Okay? So let's go ahead and do that. Let's talk about that. What's your very first coefficient going to be? Good. And that's going to be 3a to the 5th, and then negative 2 to the 0. What's my next coefficient going to be? 5. And then we have 3a to the 4th, and then negative 2 to the 1. One goes up, the other goes down. Okay? Next one's going to be 10. 3a to the 2a, negative 2 to the 2nd. Next one's going to be 10 again. 3a to the, good, negative 2 to the 3rd. Next one's going to be 5, 3a to the, yes, first. Negative 2 to the, good. Next one's going to be 1, 3a to the, negative 2 to the 5th. So you're going to notice this one's a little bit harder to simplify. Okay, this one has a little bit more work that you need to put in to simplify this. So let's talk about it. Very first one, this negative 2 to 0 is just 1. This is just 1. So our very first term is 3a to the 5th. Next one comes in, this one gets a little bit more complex. We have to do first, this is 5 times 3a to the 4th times negative 2 to the 1st power. So I have to do 3 to the 4th power in my calculator, then multiply that by 5, then multiply that by negative 2, which ultimately gives me negative 810 a to the 4th. Okay? So this is where those simplification rules come into play a lot. Okay? If you don't know how to simplify exponents, like we did in 5.1, you got to practice that. Next one, 3 to the 3rd power times 10. What is negative 2 to the 2nd power going to become? So times 4. So this one's going to give me positive 1080 a to the 3rd. Next one is 3 squared times negative 8 times 10, which is negative, I'm not looking at the right one, hang on. I just have it on the side so I don't make a mistake. Negative 720 a squared. This one here is going to be 16, which is negative 2 to the 4th, times 5 times 3, which is 240a. And then the last one, this goes to 1, this goes to 1. Negative 2 to the 5th power is negative 32. So what you're going to notice is going to happen, if you only have like one variable, it's going to decrease in exponent. But additionally, what do you notice about the signs? They're alternating, right? Alternating signs are always going to happen when you have one term that's negative. Okay, because remember, a negative term to a positive power, a negative term to an even power is going to stay or become positive. Negative to an odd power is going to stay negative. So why do the coefficients not match the numbers in the 5th row of Pascal's triangle? Because A and B are not just 1. So if they're not just 1, that's always going to change.